The cold start system on the turbo is completely automatic and has no rider-operated controls. There are three parts to the cold start system that can be tested: the air valve, reed valve, and TW sensor. You saw how the TW sensor is tested earlier. Start any test of the cold start system by testing the cold start characteristics of the engine. At minus 10 degrees Celsius, or 14 degrees Fahrenheit, the engine should run at 2,000 down to 1,100 RPM in 10 minutes. At 20 degrees Celsius, or 68 degrees Fahrenheit, the engine should run at 1,400 down to 1,100 RPM in 5 minutes. If the engine does not fast idle to specification, check the system as follows. Start the engine and let it idle. Disconnect the bypass hose from the surge tank and put your thumb over the air valve inlet to feel for suction. If there is no suction, turn off the engine and attach a pressure pump to the bypass tube. When the engine is cold, apply pressure to the tube and remove the bypass hose to the inlet manifold. Listen for escaping air. Air should exit the reeds. With the engine warm, perform the same test. Only a slight amount of air should escape. Even with the engine hot, the air valve will not close all the way. There is always a slight air bleed. To verify air valve operation, remove the valve from the engine and inspect valve movement. At room temperature, the valve should be nearly closed. Put the valve in a freezer for 20 minutes and then examine it. The valve should be open. If the engine runs rough at idle, then you'll need to test the reed valves. Using a pressure pump, apply pressure to the hose between the reed valves and the manifold. The pump should hold a reading and no air should escape the reed valve. Okay, cold start testing is performed on three parts of the system: the air valve, the TW sensor, and the reed valve. A failure in these components can cause no fast idle, continuous fast idle, or rough idle. The last area we'll look at is the automatic shutoff switch. Consisting of a pendulum in a case surrounded by oil, the switch cuts current flow to the main relay if the bike is tilted more than 60 degrees. The main relay controls power to the fuel pump, CFI system, and the ignition system. To test the switch, connect a voltmeter to the connector and check voltage to the shutoff switch. Turn the ignition on and leave the connector plugged in. Voltage across the red wire with white tracer and green wire should be 0 to 1 volts DC. Across the black and green wires, the voltmeter should read 10 to 14 volts DC. If the voltage is within specification, you'll then action test the switch. Here's how it's done. Disconnect the PB sensor and turn on the ignition. The fuel warning lamp should light. Now, remove the automatic shutoff switch from the bike. Rotate it 50 to 70 degrees. The fuel warning lamp should go out. That's all there is to testing the automatic shutoff switch. First, test voltage to the switch, and second, check the operation of the switch. Well, that about wraps up the program. You've seen how the computer readouts can provide a logical approach to complete system testing on the CX500 Turbo. And you learned how to verify pre-start sequences, test CFI system components, test the ignition timing, test the cold start system, and test the automatic shutoff switch. The information presented in this full cycle program, when combined with the earlier programs on the CX500 Turbo, has given you a solid foundation for troubleshooting, maintaining, and understanding the Honda CX500 Turbo.
Okay, here's a diagnostic kit. It's pretty much complete. Here's your fuel pressure sensor. It has a fitting, as you can see right here. These are your diagnostic cables. Sometimes when they came from the factory, they'd be wired incorrectly. So you have to make sure that yours is correctly wired. I have one here with it stripped so you can see which way it is. Okay, on the female connector over here, the red lead should be, looking from the back, should be on the right, and the green one should be on the left, and of course it's going to be inversed on the male connector right there. So on the male connector, looking at it from the back, the male connector should have the green on the right and the red on the left, and it's the inverse on the other. You're going to have the red for the female connector is going to be on the right and the green on the left. And some of these were sent miswired. If you can't find these in stock, I've got some extras, so just let me know and I can go ahead and lend you one so you can do your diagnostic. Other than that, all the other parts can be used, generic parts for it. The multimeter is commonly missing from these kits because anybody can use a multimeter for other purposes, so they tend to be missing, but any one will do. You don't need the Kawasaki one that Honda made. So that's it.